Today, you're setting up Ollama on Windows so you can run AI locally on your own PC instead of relying on a cloud chat session. I'll walk you through the install, the first model runs, and the local API test, the same practical path I use and recommend on WindowsForum. Ollama on Windows is more than just a model downloader. When you install it, you get a native app, a background local server, command line tools, and local model files stored on your machine. That matters because the prompt path stays on the PC by default. Your request goes to the local server at localhost on port 11434. Then the model runner uses your CPU, GPU, RAM, and VRAM, and the tokens come back to your terminal or app. A key thing to remember is that local use improves privacy, but a front-ender plugin can still send prompts elsewhere if you route it that way. Before you install anything, you want to confirm the PC can actually carry the load. In Settings, then System, you can verify your Windows Edition, processor, installed RAM, and basic device information. And Windows 10 22H2 or newer is the minimum target, while Windows 11 is the default recommendation. For hardware, 16 GB RAM is the floor for small models, 32 GB is the better desktop target, and an NVIDIA RTX GPU with 8 to 12 GB or more VRAM is the safer mainstream choice. If a machine is lighter than that, start small and expect slower inference or a fallback to the CPU. A model's downloaded file size does not tell the whole story, so you want to think about runtime pressure too. Ollama has to juggle model weights, runtime buffers, the context window and KV cache, plus whatever windows and your other apps are already using. That is why a model can seem like it should fit on paper and still run slowly, fail to load, or push the machine into CPU-only mode. For most desktop users, QN34B is the safe first run, QN38B is the stronger everyday choice, and 30B or 70B plus models are simply too demanding to start with. You start here because the hardware tells you how far you can push local AI before it slows down. On screen, you open Settings and click System, so you can confirm the Windows Edition, processor, RAM, and basic device info. If the machine is light on memory, that's your signal to stay with smaller models first instead of jumping ahead. If System doesn't show what you need, use the About area or another device info screen to verify the specs before you continue. Now install Ollama itself. It gives you the Windows app, the local server, and the command line tools used in the rest of the walkthrough. In normal PowerShell, copy and run the command shown on screen from Ollama's Windows page. On the Windows 365 test machine, the real installer downloaded Ollama for Windows, installed it, and ended with install complete. After that, start the local server if needed, then begin with QN3,4B because a small model is the lowest risk way to verify the install, model download, and local inference path. Start small. With the local server running, pull QN34B first. On the Windows 365 test machine, the poll downloaded the model, verified the SHA-256 digest, wrote the manifest, and succeeded. The real installed model size was 2.5 GB. After the poll succeeds, you can run it with Ollama run QN34B or call it through the local API. Once the small model works, check headroom before jumping to a larger model. On this Windows 365 cloud PC, QN34B loads at about 3.2 GB and uses 100% CPU. That means QN38B is not the right first benchmark for this 8 GB CPU-only box. Next, review local models with Ollama list. The verified Windows 365 output now contains the installed QN3,4B row and a size of 2.5 GB. This proves the model is stored locally on this PC and helps you check disk usage before adding more models. Now check what Ollama currently has loaded with Ollama PS. On Windows 365, QN3,4B is loaded at about 3.2 GB using 100% CPU, with a 4096 token context. That load check matters. 3.2 gigabytes is the runtime footprint. 100% CPU means CPU-only execution, and context 4096 is the conversation window. To prove the model actually responds, send a simple hello request to Ollama's local API. The request goes to localhost port 11434 and targets Qwen 3, 4B. On the Windows 365 Cloud PC, the API returned HTTP 200. The final model line was, "Hello, welcome to WindowsForum. Let's chat about Windows together." This CPU-only Cloud PC took much longer than a desktop with a real GPU would. That is the trade-off with local AI. Privacy and control, but you still need enough memory and compute. Start with a small model, confirm it works, then move up only when the machine has headroom. Now you know how to install Ollama, check local models, and test a local AI request from Windows. Keep following WindowsForum.com.